Find the vector equation of a line passing through a point P which is 2, 5 and is perpendicular to vector R with this equation. So now when two vectors are perpendicular to each other, it means their directions, when you multiply their direction, you should have a 0, or when you multiply the two direction vectors, you should get a 0. In other words, their dot product is a 0. But we have an easier way of finding the other gradient given one gradient. So I'll take you back to grade 10, where you were told that when two lines, straight lines, are perpendicular to each other, then their product is -1. In other words, when two lines are perpendicular to each other, then their gradients are negative reciprocals of each other. So if my first gradient is this, to get my second gradient, all I have to do is reciprocate and negate. The same applies to this. So this is the direction. The direction here, if I may call it M, is 2, -3. So now if you were to convert this to the other form for like linear equations, this would be, remember this is your y, this is your x. And then to find the direction of this or the gradient of this, you can simply say y divided by x. And the reason is very simple, because when you're dealing with OM, so to find the when OM is this, then we are saying this is starting from O, which is rho, 0, to this point, which is 2, 3, 2, -3. So your M here will be, you can just say y1 minus y2, then x1 minus x2. So you can say y2. If this is your y2, you can just say -3 minus 0, and then you have 2 minus 0. But because this is always a 0, your gradient here is -3/2. So the other gradient, if this was perpendicular to this, then the other gradient would be, you reciprocate this, so this would be 2/3 and negate. Since the 3 was a negative, you can make it a positive. So now the same applies to this. To get the direction from this vector, all you need to do is reciprocate this and negate one of the two. By negating, I mean make it the opposite of what it was. If it was negative, you can make it positive, but not both. Just pick one and negate it, because when you negate both, then you haven't done anything. So in other words, what I'm saying here is the direction of this vector is 2, -3. The direction of a line or a vector perpendicular to this will simply be swap these two numbers and then negate. So this one was a negative, I'll make it a positive. If you want, you can make this one a negative so that you have both negative numbers, but nobody wants to deal with negative numbers when they have a choice. So I'll go with this, and then you can just get any points on the line. Remember, it's perpendicular to this and passes through this. So that means R is equal to A plus lambda B. So we have R is equal to A, which is this one. You can write it in column vector form, plus lambda. Our B here is 3, 2, and you're done. On part B, we have the points A and B have position vectors this and this respectively, where T is a scalar Then 0.28i plus 0.96j is a unit vector in the direction of AB. Find the value of t. So what we are being told here is that the unit vector in the direction of AB is this. So all you have to do is find your AB and then find the unit vector in the direction. So your AB will be, you get, okay, let me just do it like this. AO plus OB, where OA is the position vector of A, which is this one here. So we have 5i minus 7j. And then OB is the position vector of B, which is ti plus 17j. So then AB will be AO, just swap this, 5i minus 7j, and then plus OB, this is ti plus 17j. And then AB is, we have negative 5i plus 7j is equal to ti plus 17j. So now you can put the i's together. Negative 5i plus ti, then the j's together. This is just 24j, because 17 plus 7 is 24. Then you can factor out the I plus 24j. So now what the question is saying is the unit vector in the direction of AB is this. So all you need to do is find the unit vector in the direction of AB, equate it to that, and then you can solve for t. So to find the unit vector in the direction of AB, you normally use this AB cap. You write this exactly as it is, plus 24j, then everything over the modulus of the same thing. So then this will be negative 5 ti plus 24j, then everything over, you say the square root of negative 5 plus t squared plus 24 squared, and then this will be negative 5 plus ti plus 24j. Then you can square this. When you square this, you have 25. I'm using binomial, minus 10 t plus 10, I mean t squared, and then 24 squared, is it 624? Let me just verify that. 24 squared, it's actually 576. And then this will be negative 5 plus ti plus 24j, and then like terms together, this plus this, 20 plus 25, we have 601 minus 10t, then plus t squared. So now this is supposed to be the same as this. So this is supposed to be equal to this. So in short, this is the same as, let me write the unit vector, 0.96j. So now at this point you can equate, or maybe you can separate these and then equate the i's with the i's, the j's with the j's. I didn't expect this from this problem. So we have 5 ti over the square root of 601 minus 10t plus t squared, and then plus 24 over the square root of 601 minus 10t plus t squared. So this is j. Then this is the same as 0.28i plus 0.96j. So now let's separate and equate. So you can get this and equate it to this, and then this and equate it to that. So you may not need both, just pick one. Whichever will be easier for you should work just fine, since t is still the same. So since we have an option, I'll go with this and this. If you want, you can go with this and this, but because of that, you may be required to do a bit more work. So I'll go with 24 over the square root of 601. No bullying. Okay, so I'm at school right now and the kids are saying no bullying. So to solve this, you can cross multiply. So you say 24 is equal to, this will be 0.96 601 minus 10t plus t squared. And then to make it easier for me, I can just divide both sides by 0.96, because I know that this one can go into this just fine. So we can say 24 divided by 0.96, this is 25, is equal to 601 minus 10t plus t squared. And then to solve this, you can square both sides so that you get rid of the square root. So this one will be 625. Then this side, the square root will be eliminated. And then at this point, you can just take everything to one side and then solve for the unknown, because we have a quadratic equation now. So this and this will be 25 minus, this is more like 25 minus 1. So that's 24 minus 24 minus 10t plus t squared. So the product here is minus 24. Then the sum is minus 10. So the factors will be 6 and 4, I think. This time, yes, no. 6 times 4, no. These will not be the factors. So for 24, we have 6 times 4. We have 3 times 12, no. 3 times 8. We also have 2 times 12. Okay, so the factors here are 2 and 12. So we have 2 and 12, and because we want both numbers to be negatives, so we can have that. So you can say 0 is equal to, let me just write them this side, t squared minus 10t minus 24 is 0. So I have t squared, I'll start with plus 2t, then minus 12t minus 24 is 0. And then you can factor the t out, plus 2, you factor the 12 out, you have t plus 2 is 0. So this one will be t minus 12, then t plus 2 is 0. So we can therefore conclude that t is either 12 or t is minus 2, and you're done.